Hello everybody, and welcome to the second video on if statements. So in this video we simply continue what we started with last time and build on the if statement material. So we will talk about what are called nested if statements. These are if statements inside of other if statements. And then we'll talk about some other Boolean statements that we will need to use if statements as we keep going through the course. So first, consider an example like this. You have a program that lets a user play either chess or checkers. And once the user chooses a game, you ask them a follow-up question, which is, do you want to play easy or hard? So the user first chooses a game, and choosing a game sets the computer down one of two paths, right? You can either do a chess path or a checkers path. And then once you're inside of each game, you can ask, oh, do you want to play easy or hard? So recall that this initial branching, right, where you're giving the computer two mutually distinct branches to go down, that requires an if statement. Well, once you've done that if statement, now you're inside the if statement here, you can introduce another one that branches between easy and hard. So what does that look like? You get a response from the user, right, what game do you want to play? And then they tell you. If that response is checkers, then you go into the checkers code. So you say, okay, let's play checkers. Enter 1 for easy and 2 for hard. So this X variable lets the user choose easy or hard. So you grab that from them. And now, if X is 1, you taunt them for being so cowardly, and then you would do the easy mode code right here. Otherwise, if X is 2, you could say, always on, and you do the hard code. We go right here. So notice I have an if right here. This if statement opens its brace there, closes its brace right there. Okay, so all of this stuff is inside that if statement, and inside of that if statement is another if statement. All right, so you have if inside of if. Notice you could have if inside of if, inside of if, inside of if you want to. You can just keep nesting. So this is a nested structure right here. So in a diagram like this, that would correspond to, once you've chosen easy, maybe there are other choices the user could make. Like, do you want to be the white pieces or the black pieces in chess, right? So the program branches initially between chess and checkers. Once they've chosen chess, it branches between easy and hard. And once you've chosen easy, you could branch between white pieces and black pieces. Over here in the checkers branch, once they choose easy, you could branch between red and black, right? Those are the two colors there. So in any case, you can make if statements nest as much as you want to. I would say that if you're doing if inside of if, inside of if, inside of if, right, it just gets insanely complicated. You should find a different way of doing all of that. Okay, but in any case, the computer will let you do it. So let's just go to the compiler and let me show you the full code. So the full code over here doesn't fit on the slide. Here's what all the code looks like. What game would you like? They give you a response. If the response is checkers, here is the code from the slide. So checkers, 1 for hard, 2 for easy. Or if they say chess, and I guess this is fine, but let me make it a literal branching. Otherwise, if their response is chess, then we do the chess stuff, right? I added an extra line here. If X is 1, you taunt them. If X is 2, you say it's on. If they enter something else, like a 3 or a 4 or something, you tell them, I didn't recognize that. I was expecting a 1 or a 2, and you put something else in there. So I will post this sample code on Moodle so you can play around with it if you want. But here's a nested if structure. Before I leave the compiler, let me point out one thing, which is that the indentation here, the way this code is laid out, is the proper way to lay it out for a reader, so somebody like me. So the computer, for example, doesn't care about indentation. The computer doesn't care about aesthetics, right? Because the computer is not human. But I could have written the code like this, without the indentation. This is now pretty hard to read, okay? That will run just the same, but it's hard for another user to read. So that is why we indent. So once we're inside the if, we start indenting. And then here, we're inside of another if, right? So this cout is inside of this if, which is inside this if. That's why there are two indentations there, and so on. So this is how the code should be laid out to make it easy for me to see what's going on. Oh yeah, so I guess I should run this so we see that it works properly. So I'll type, checkers. Did not print anything to me. Let's see. I want to play checkers. Okay. So checkers time. Enter 1 for hard, 2 for easy. I will choose hard. And it's on. Okay. If I do the same thing, let me do chess now. I'll do easy. Whoops. Oh, chess. I switched these, right? Enter 1 for easy and 2 for hard. Is that the way it is up here? Yeah, so I switched these from the screen, from the slides. Let me just fix that real fast. I need to make my instructions match what's actually happening. So chess, 1 for easy, coward, right? So it's working the way you want it to. So again, that code will be on Moodle for you to look at and play around with if you want. Okay, so now let's move on to other Boolean statements. So suppose you're writing a program and you ask the user, do you want this program to run? This is kind of a silly question, I guess, because presumably they do, but let's just go with it. So the user enters yes, like this. If they do that, you should want the program to run. But what if they do this? Presumably, you still want the program to run. So you would need some sort of structure like this. You get the response from them. If the response is either little yes or uppercase yes, the program should run. The problem with this is that C++ does not recognize the word or. What it recognizes is vertical line, vertical line. That's how you say it with the word or in C++. So if you write this, then you of course have the right idea. That's what you're trying to get the program to do, but you have to speak the proper language. You have to speak C++, and unfortunately the word or is not a C++ word. So the way you would actually do the above is if response is little yes or response is upper yes, then please run my program. And by the way, you do need response is yes or response is yes. You can't say response is yes or yes. You see, you can't take this out of there. You need that there. Sometimes it will behave properly, sometimes it won't if you take that out. But if you just be safe and just write out fully, right? If response is lower yes or response is upper yes, then please do this. So in C++, the word or is 2 vertical lines. The word and is 2 ampersands. The word not is an exclamation mark, just like in not equals from last time. Okay, so let's just walk through how you're going to tell the computer various things using this notation. Suppose you care about this. If the value of x is between 1 and 6, and it could also be 1 or could be 6, right? X is bigger than or equal to 1, less than or equal to 6. The computer will not recognize that. What it will recognize is this Boolean statement. What you really mean when you write something like this is x is bigger than or equal to 1, and simultaneously x is less than or equal to 6. So if you want the computer to just do something if x is between 1 and 6, that's how you would have to type it. So a common mistake is to confuse these two, right? To confuse and or. So for example, do you want to play my game? Whatever. Yes or no, get the response. What you mean here is if response is little y or big Y, you want to play the game. You don't mean and here. So the response cannot simultaneously be little y and big Y. So this statement in here with an and is always false. Okay, you will never run this if block. If you change this and to an or, right, this vertical line, then if response is little y or big Y, the subsequent block of code will run. So finally, we have to delve into a little bit of logic here because the statement A or B, that's a Boolean statement. It's raining outside or it's dark in my room, whatever. That statement could either be true or false. So the question is, when is an or statement true? So let's think about that. If A is true or B is true, or actually both of them are true, then the overall statement A or B is true. So the statement A or B is true most of the time. The only way that this statement is false is if both A and B are false. In any other eventuality, if A is true or B is true or both A and B are true, the statement itself, A or B, will also be true. So here's an or statement, right? I'm the best professor ever, or it's 110 degrees outside. So presumably you were watching this in February or something, so this statement right here is false, isn't it? That's usually false. But this statement right here is true. So even though there's some falseness embedded in this statement, the overall statement, this or this, that overall statement is considered true. Okay, by contrast, when is the statement A and B true? This is more straightforward. A and B is true if and only if both A and B are true. So in this example here, if I change this or to an and, this is still true. I'm the best professor ever. This is false. So in an and statement like this, both things need to be true for the overall statement to be true. So if I change this to and, then now the overall statement is false. Okay, so finally, we need this law from logic called De Morgan's law. So what I'm about to show you will most likely trip you up sometime. Okay, so it's not a big deal. You just have to get used to it. But imagine asking the user, as we just did, 1 for easy, 2 for hard, right? Then what you want from the user is either a 1 or a 2, right? You want them to enter a 1 or a 2. If they enter something else, like say a 7, you would like to tell them, hey, I didn't expect a 7, please enter a 1 or a 2, right? You want to tell them somehow that what they entered was invalid. So how do you represent everything invalid? Well, if this is what's valid, then not that, right? Not this thing right here. Those are the invalid things. So invalid is the not of the valid. So how do you treat not A or B? What does that even mean? What does it mean to say not this or statement? What it means, and this is De Morgan's law, not A or B is the same thing as not A and not B. So if you take an or statement and you decide to look at the opposite of it, the not of it, you will change that or into an and you will negate each individual statement. So here, not x equals 1 or x equals 2, that's equivalent to saying x is not 1, oh, and also x is not 2, right? So the opposite of x being 1 or x being 2 is that x is anything else. So x is not 1 and also x is not 2. So here's an English example. My name is David or my name is Mark. If I not that, so I look at everything but that, it's the same thing as saying my name is not David and my name is not Mark. So in other words, neither the word Mark nor David could be my name, right, is what I'm telling you. So as I just said above, right, not x equals 1 or x equals 2 is the same as this. So you would say in the code this, if x is not equal to 1 and also x is not equal to 2, you tell them the input is invalid, okay? So what students get confused here with, and this is perfectly natural, right? This is confusing. Let me just get all of this out. Okay, so string response, oh, sorry. Doing it with an integer, right? Int x. Okay, so if x equals 1, then what? Well, if x equals 1 or x equals 2, I'm sorry, let me set this up again. If x is not equal to 1 and x is not equal to 2, I'm supposed to tell them things are invalid. Okay, and of course I should grab x, I suppose, right? So let's see that this works. So let's say I enter 7, right? It tells me that's invalid. I was expecting a 1 or a 2, and you gave me not that. If I enter a 2, notice it doesn't print anything because it skips over this if, because 2 is valid. If I enter a 1, it skips over because 1 was valid. But again, if I enter like a 15, it says, oh, that's invalid. I was expecting a 1 or a 2. Okay. So the common mistake that I see is not to put an and there, but to put an or there. Okay. So you take x equals 1 and x equals 2, you negate those things, but you keep the or as an or. So let's run this and see what the computer thinks about this. So suppose I enter a 7, okay? 7 is not valid because 7 is not equal to 1 or not equal to 2, right? So if I hit enter though, oh, it says invalid. So it worked properly. Okay, that's good. So far it's working properly. Now let me enter a 2. Oh, see, before when I entered a 2, it skipped past this, didn't it? Because 2 was valid. But now when I enter a 2, suddenly it thinks 2 is invalid. And what if I put a 1 there? It thinks 1 is invalid too. Okay. What if I put a 10 there, whatever? So it turns out that in this setup here, with an or right here, the computer will actually think that anything is invalid. So why is it that if I put a 2 right here, why does the computer think that this statement is true if x is 2? So if you think about it, if x is 2, this statement here is false, isn't it? 2 not equal to 2 is a false statement. But 2 isn't equal to 1. So this statement here is true. And when you're dealing with an or, if only a single piece of the or is true, then the overall or statement is also true. So if you really want the computer to accept valid things and not accept invalid things, you need an and right there. So now if I put a 2 there, it doesn't tell me invalid. But if I put an 8, it still tells me invalid. Okay, so this is one of the most common mistakes. I think that's what I have here, right? Or. So this will happen to you probably at least twice in the semester. It's frustrating, but you just have to get used to using these symbols and used to remembering De Morgan's law, basically. You have to say to yourself, ah yes, x equals 1 or x equals 2. Those were the valid things. So when I negate that, I have to have an and. Okay, so you can also negate and statements if you need to. If you negate an and statement, what happens is the and actually turns into an or, and you still negate each individual piece. So if I told you, hey, I had pizza for dinner and I drank Dr. Pepper with dinner, right? That's an and statement. If I want the opposite of that, if I want to negate it using a not, that would be the same thing as I didn't have pizza for dinner or I didn't drink Dr. Pepper with dinner. So you negate each individual statement and change the and to an or. So I may have had pizza, but in the case that I did have pizza, I didn't have Dr. Pepper and vice versa. So I may have had Dr. Pepper. If I did have Dr. Pepper, I didn't have pizza. So one or the other has to be true. Okay, so at the conclusion of this video, you should be comfortable with basically two things. You should be comfortable with nested if structures like this. The idea of branching, then branching again, and then maybe branching again. Okay, the idea of nested ifs. Then you should be comfortable with this and, or, and not notation. So you should be comfortable writing things like this. If response is yes or response is yes. And you should keep in mind that when you negate an or statement, like we did where? At the end here, like we did here, if you negate an or statement, what you end up with is an and statement. So if you ever want to tell the user, hey, what you did was invalid, you will need an and statement. Okay, so that's it.